Hello guys, welcome back to my channel Average Programmer. Today we are going to discuss about merge sort algorithm. Merge sort algorithm. It uses the technique of divide and conquer to sort the array elements, and the time complexity of the merge sort algorithm is big O of n log n. If you want a video on time complexity, comment down in the comment section. I will make the video. Coming to divide and conquer, if you consider a problem P, which is a big size problem, we can divide that problem into subproblems P1, P2, P3 and so on until Pn. The solution of the problem P1 is S1 and solution of problem P2 is S2 and so on. We can get the solution of the problem P by combining the subproblem solutions. Before getting into merge sort, we'll discuss one problem. These two A and B are two sorted arrays, and I want to join these two sorted arrays such that the final resultant array is also a sorted array. If you don't get the problem, listen carefully. A is an sorted array. B is also an sorted array. I want to join these two sorted arrays such that the final resultant array should be a sorted array. You get my problem, right? Yeah. And if we consider the time complexity of this problem, we take the size of array A is n and size of array B is m, then we can solve this problem in the time of O of n plus m. Think of how we can do it. Pause the video and think and solve this problem. If you can't, just watch the video. Yeah. We will consider two pointers I and j. I is at the first index of A and j is at the first index of B. We will take a new array C such that we can add the elements. First of all, what we will do is like we will compare A of I with A of j, B of j. Here A of I is 1 and B of j is 2. We have to compare. If A of I is less than B of j, then we will add A of I to C. Otherwise, we will add B of j to C. Now, A of I is at 1 and 1 is less than 2. Then we will add 1 to C. Now, I move to second one, 3. Now, I is at A of 1, that is 3. Now, we will compare if A of I is less than B of j, which is wrong. So, we will go to next part. If B of j is less than A of I, then we will add B of j to C. So now we add B of j, that is 2 to C. Then j will move to next part, next index. Now we will do the same thing, comparison. A of I is less than B of j. So 3 will be added here. And I will move to next part, next index. Now if A of I and B of j is compared, now j is moved to next index and 4 is added to C. Such that we will go like this. Now, coming to the last index of A, 7 is less than 8. So we will add 7 here. And I should move to next index, right? But the array is ending. Then what we will do is like, we will write a condition in the starting of the problem that if I is less than length of A and j is less than length of B, then only we will continue with the problem. If any of these condition fails, that means the pointer has overflown the array. That means last index is also crossed. There are no elements in the array. Then what we will do with the remaining elements of the left array is we will simply add those elements to the C. If you consider this one, 8 and 10 will be left over. Once I cross the 7, then 8 and 10 will be left. Then simply what we will do is like add 8 at the last and 10 at the last. Because it is a sorted array, it will be in the sorted order. Now you get it? Then now consider the time 0, 1, 2, 3. This is of size n. Then the loop will run until n times. It will be m times. What will be the time complexity? O of n plus n. Now we will see this problem in action. Yeah. Consider two arrays A and B. A is of size 5. 1, 2, 5, 8, 9. Size is 5. B is 3, 6, 7, 10. Size is 4. We are considering two pointers I and j. As discussed earlier, I and j both will start at 0 index. While considering this overflow condition, we will write while I is less than length of A. Length of A is 5 and j is less than length of B. Length of B is 4. If first we will get to the first iteration. If A of I is less than B of j, what is the first iteration? I will be at 0, j will be at 0. If A of I is less than B of j, then what we are doing? We are appending that element to C. After appending that element, we have to shift that I to next element, right? I plus 1 will do that thing. If this condition fails, consider this case. J is at B of j is at 2. A of I is at 3. This condition fails. A of I is less than B of j is wrong. Then what it will go? It will go to next part. Else if B of j is less than A of I, B of j is less than A of I, then it will append B of j to C. It will append B of j to C. Then what we have to do? We have to move the j to next index. We have to move j to next index. We have to do until when one of the array should end, right? I will come to last element and it will overflow, and j will be at 8. Considering this problem, j will be at I will be at 9, and it will close the array. Sorry, we'll discuss it later. This problem is different. We have to write this code for q p in range of I comma 5, for q in range of j comma 4, to add the extra elements which are left over in the arrays. As it will as the I and j values are not changed here, it will be updated I and j here once the traversal is completed. Then what we will do is like, after adding leftovers of both arrays, then we will simply print C. Let's execute this problem. Yeah, as you can see, the resultant is the sorted array. How much time did it take? O of n plus n. Here O of 9. O of 1 actually. I will make one video on time complexity, then you will get it. Yeah. Now we will see the relation between this problem and our merge sort. Let's go into example for one merge sort problem. Consider this array of size 8. Array of size 8 means 0 to n minus 1 index, 0 to 7. In merge sort algorithm, we will do the divide and conquer method as we discussed. The dividing will be in the order. What is that order? We have to consider left index as left, right index as right. We have to divide the array from L to mid minus 1, and from mid to right we have to divide it to another problem. How we can get the mid equal to length of array by 2. Here length of array is 8. 8 by 2 means 4. Mid will be at 4. From L to mid minus 1 will be one part. From mid to R will be another part. As you can see here, It is the same array down here, 1 5 8 6, and the second array is 2 3 10 4. We'll do the same technique until we divide the array into single element arrays. If you are familiar with recursion, recursion is function calling within the function. We'll call the function until the array length of the array is 1. Once it is done, we'll store this array in L, this in R, L, R, L, R, L, R. Now you have two arrays, L and R. Now you have to join these two arrays. As discussed earlier problem, it is a simple linear time complexity problem. We'll join these two arrays 1 and 5, 8 and 6. We'll use same pointers and join these two arrays. 6 will come first. As 6 is less than 8, 6 will come first. Now this is an L array, this is an R array. These two are two sorted arrays. As we discussed earlier, combining these two arrays, we get the resultant array as sorted array. Now we are joining two sorted arrays and the resultant should be sorted array, right? So that the final array will be sorted. Now we are joining these two arrays, L and R. 1 5 6 8, right? These two are already in sorted array. We will just join it. I will take one more example. Consider same case with which is take 2 4 3 10. These two are two sorted arrays, right? 2 comma 4 is sorted, 3 comma 10 is sorted. While combining these two, we will get I j. A of I is less than B of j. So we will add final array 2 to final array. I will be moved to here I. B of j is less than A of I. So 3 will be added, 4 and 10. Now you get it, right? It is the same problem we discussed earlier. It is the same problem here. You have to do it until the final array is sorted. This is the merge sort algorithm. If you don't get it, please rewind the video. Please go back and watch it again. If you still have any doubts, please type that in the comment section. I will get it clarified. Now we will write the code for this merge sort algorithm. Yeah. There is an array. I'm printing the array before sorting and I'm calling the function merge sort. I'm printing after sorting. I'm passing the argument array A. ARR here. Yeah. Let's do it. What we have to do? We have to divide the array. Until when? If length of ARR greater than 1, then we have to divide. What we have to do to divide? We have to find mid first. Mid equal to length of ARR by 2. Here double by means integer division. Yeah. We'll store it in the temporary variable L equal to ARR of colon mid. If you know the slicing method, then you will get it. ARR of mid means it will consider until before element of mid. That means R equal to ARR of mid colon until last. Yeah, we got L and R. Now what we have to do? We have to further divide that L and R until we get the single element, right? How we can divide it? We can simply call the same function merge sort of L, merge sort of R. It will divide until length is less than 1. Length is equal to 1. Yeah. Once it is done, it will come back. As it is recursive, it will come back in the function. Now we have two arrays, L and R, which are sorted arrays. As these two are single array elements, I will show you a fun fact. If an array have only one element, is it sorted or not? Obviously, it is a sorted array. So we have two sorted arrays. If we consider we have only single element arrays, then what we have to do? We have to combine those two arrays. While first we have to declare I, j, k equal to 0, 0, 0. As we are using these pointers as indexes from starting from 0, and we have to we do no need to declare third array. We'll simply replace it in the ARR while I less than length of L and j less than length of R. Now what we have to write? Considering if L of I less than R of j, then AR of k equal to L of I. We have to increment I and increment k, as we have to move through the C array, right? Third array. We will also increment k. L if R of j less than L of I. Then we have to add AR of k equal to R of j. We have to increment j and k. Yeah. We are done until if the length of both arrays are different, we'll get only completion of one array. Maybe, we don't know the condition. For adding the remaining elements of the leftover array, we'll write a loop for p in range of I comma length of L. AR of k equal to L of I plus equal to 1, k plus equal to 1. It is the same program we wrote earlier. You can check it. Here I appended it. Here I am just adding it, as it is the size is already declared in the ARR. Yeah. Length of R. Yeah, we are done here. That's it. We did the merge sort algorithm. It is that simple. You can verify the code again. What we are doing? We are dividing the array until we'll get the single digit array. Then what we are doing? We are storing that single digit array in L and R, and we are merging those single digit arrays, and next we will get two digit arrays. Those are also will be stored in L and R. If you want me to explain in the recursion, I will show you. Once it is divided, it is L and R, right? It will call the function until this part. Then it will come back. It will come back to same stage here. Here. Here what is there? L is stored as here. R is stored as this one. Then what we'll do is we'll sort these two arrays, I mean join these two arrays as discussed in the earlier problem. Actually what is happening, like, it is not going in this way, it is coming back in this way, recursion. It is coming back, right? That's it guys. That is merge sort algorithm. If you have any doubts, please type it in the comment section. I will clear it. I will try to make videos on time complexity, recursion, and whatever you want. Please ask it, and I will make videos on that. Thank you guys. Meet you guys in the next video.